Hello, this is Mr. Agbamu Idano. Today I'm going to teach you how to solve some problems on the topic coordinate geometry. And I'm going to focus on these past questions, JAMB past questions and WAEC past questions. So the first question I have here is taken from JAMB 2000 and the type I have here is type A. So take note of that. So let's start with this question. So the question says 3y equals to 4x minus 1 and ky equals to x plus 3 are equations of two straight lines. So you can see the two equations are given, the first equation and the second equation, but k is not known in this second equation. So then I say if the two lines are perpendicular to each other, find k. You can see what the question is saying. So this is under perpendicularity, because they gave us two equations and they said the two equations are perpendicular. So if these two equations are perpendicular, how can we get the value of k? All you need to do in this question is to get the gradient of both equations. Then after getting the gradient of both equations, then use the condition for perpendicular lines. Then from there the equation will be over. So if you start with your solution, which is first you find the equation of both, you make y the subject. So that is the best way to get the gradient of both lines. So if you want to get the gradient of any line, just make y the subject. So make y the subject. Make y the subject in both equations. So if you make y the subject in both equations, let's start with the first one, which is 3y equals to 4x minus 1. Then if you make y the subject in this case, you are going to get 4 over y. That I divide each term. When you divide each term by 3, so you divide each term by 3, this is going to give you y equals to, so 3 divided by 3, here we go, it will be 1. Then 4 divided by 3, we have 4 divided by 3 x, then minus 1 divided by 3. So with this, you have made y the subject of the equation. So that is this. And if you recall, let me put it down. If you recall, you remembered our general form of equation of a line. Remember when we did it in one of our classes? You see, equation of a line, the general form of equation of a line, we have y is equals to mx plus c. And remember what we said then? We say m is the gradient, then c is the y-intercept. So in this equation, if m is the gradient, when you compare this equation to this, you see that the gradient m is equals to 4 over 3 in this first equation. So just take note of that. Now say therefore gradient m. So let's call this one m1. Let's call this gradient of this first line as m1. So gradient m1 is going to be equals to 4 divided by 3. So that is the first equation. Okay, let's move on. So if I make y the subject in the second equation now, which is the second one, I'm going to have ky is equals to x plus 3. So if ky is equals to x plus 3, then divide each term by k, I'm going to have y is equals to 1 over kx plus 3 over k. That means when you divide each term by k, just the same way you did this, the coefficient of x is going to divide 3. That's how we have 4 over 3. The minus 1 is going to divide 3 when you divide each term by 3. So the same thing here, when you divide each term by k divided by k is 1. Then 1 over k, 1 is the coefficient of x, 1 over k is here, x plus 3 over k. So with this case now, the next thing is, when you recall with our general form of equation of a straight line, you will see that m2, which is the second line now, the gradient m2 is equals to 1 divided by k. So that is it. So now that we have gradient of both equation, what is the condition for perpendicular line? Remember the condition for perpendicular line. We say since both lines are perpendicular, since both lines are perpendicular. So since they are perpendicular, therefore we are going to have, you know the condition for perpendicular now. We said perpendicular line says m1 times m2. The m1 times m2 is equals to minus 1. So this is the condition for perpendicular line. Then all I need to do here is, these two now, we need to substitute them. From there, k can be solved as a simple equation. So m1 is 4 over 3. So you have 4 over 3. You multiply it by m2 is 1 over k. 1 over k, then equal to minus 1. Then you can now solve this simple equation now to get your answer for k. So that is all it is. And to solve this, you multiply the numerator. 4 times 1 is 4. Get your 4. 4 divided by 3 times k, 3k, which is equal to minus 1. Then in the next stage, now you cross multiply. When you cross multiply, you are going to have 4 is equal to, 4 equals to 3k times minus 1, which is minus 3k. Then the next thing is to divide both sides by minus 3. So divide both sides by minus 3. Minus 3 will cancel out minus 3 here, leaving 1. So your answer for k will now be equals to 4 divided by minus 3. So that is it. So that is the value for k. So k is also equals to minus 4 over 3. You can also leave your answer in this form or in this form, but most times we prefer the negative to be on the numerator, since plus divided by minus is minus, so you leave it as minus 4 over 3. So this is the value of k in this equation. Take note of that. So when you have these two lines that are perpendicular to each other, then the value of k is going to be minus 4 over 3. Take note of that. So that is one beauty with that. So that is all for this first question. K is minus 4 over 3. Let's try another question. Let's see. So this one I have here, I'm taking it from 1999, number 18. It's also type A question, and the question says find the equation of the locus of a point P, x, y. So this is the coordinate of a point on the locus. You know, when we say a locus, we are talking of a set of points that are being formed according to a particular rule. And most times this set of points, they are along a particular line. It can be a straight line. The locus can be a straight line. The locus can be a circle. The locus can be a curved line. Just depends on the locus. But this locus now, they say it has a point there's a point on the locus which has coordinate x and y, and there's a condition I say such that this point on this locus P to point V is equals to 1, 1. The coordinate of V is 1, 1. Then the coordinate of W is 3, 5. So the distance between P to V is equal to the distance between P to W. So that's what they are talking about. And how do you solve this question? Remember, the question says find the equation of the locus. So that locus that will be formed is a line. So take note of that. The locus is not just a point, but it's a line. So how do you get equation of this locus? And all you need to do in this question is to analyze this question very well. We need to look at V and W first. V and W, there are 2 points. You take note of that. Then P to V, you see P to V is a distance now, and the distance is also equals to P to W. You get what we are doing? It's just like something like this. Let me demonstrate it with this graph so that you get it well. The question says we have a point. Let me just put value. Okay. So the question says we have a point. Let's take V as the first point, 1, 1. The other point is 3, 5. So if I have 1, 1, that means when x is 1, y is 1. You get this point. You can see it. Then 3, 5, when x is 3, y is 5. You see, so these are the 2 points. So these 2 points now, you can connect them with this line segment. You connect this line, this point to this point. Then there's a locus. So a locus is someone, I told you that locus are a set of points that are being formed according to some rules. So locus can be a straight line. So it can be a circle, just depend. But in this question now, this locus has a point. So there's a point on that locus. So let's just take somewhere, let's just assume a point is somewhere here. So there's a point somewhere here. They didn't give us the coordinate of that point. If you look at the question says this point, the coordinate is x and y. They did not give us the coordinate. So, and the question don't even want us to find this coordinate. All they want us to find is the equation of this locus. So let's see. So if there's a point somewhere, the distance between this point to this, see, is equal to the distance between this point to this. That's what they are saying. So if you can get the distance from this point to this, it will also be equal to the same distance from this point to this point. But without wasting time in this question, the only time whereby you are going to have the distance from this point to this point to be equals to this point to this point. That means the only time distance G will be equals to distance H is when this point passes through the center. When there's a line that passes through the center of these 2 points, that is the only condition you can have that. So what I'm trying to say is it is only a perpendicular bisector that point P can stand such that distance from P to this point will be equal to distance from P to this point. So that's what the question is trying to say. So if you can get a perpendicular line that passes through the middle of these 2 points, then we can easily get the equation of that perpendicular bisector. That's what the question is trying to say. So take note of that. I just want you to understand the question. You know, as I told you, this topic is more of a formula calculation. We don't usually need any graph work. You don't need to plot the graph. Remember, this is a JAMB question, just objective question. So in less than 1 minute, you should be able to solve this question. And if you don't understand the question, you'll just be looking and you lose this mark. And each mark count in this exam. So what you need to know with this analysis is point P is standing on a perpendicular bisector. So that is where we are going to start from. So the locus that we need to get the equation now, say the locus is a perpendicular. It's a perpendicular bisector. Perpendicular bisector. So that is the locus of points V and W. So this is very, very important. So the locus is the perpendicular bisector of point V and W. So if you can get the equation of that perpendicular bisector, that will be this equation the question wants us to do. So how do we get that? Number one, we need to get the middle point of this V and W. So we need to get the midpoint. So you start with the midpoint. The midpoint of VW is, remember we did midpoint the other time. So we say midpoint, you get your x1 plus x2. So since it's v and w now, so x1 is you can see it is 1, x2 is 3. So all you just need to do is to solve them like this, which is for the first point now, for the first coordinate x, s is going to be equals to 1 plus 3, so x1 plus x2, and divided by 2. Then you can easily solve this and get the answer. So this is 1 plus 3, 4. 4 divided by 2, the answer is 2. So if you leave that one, then the coordinate of y, we'll bring this down. Okay. Then the coordinate of y now, so y is going to be equals to, for y we are going to have 1 is also y1, then 5 is y2. So you have 1 plus 5 divided by 2, and this is going to give us 1 plus 5 is 6, 6 divided by 2 is going to be 3. So that is that, take note of that. So the coordinate now, so the midpoint now, so midpoint is equals to, the midpoint is going to be equals to 2, 3. So this is the midpoint. So now that the midpoint is known, and remember the line passes through the midpoint, you say find the equation of the locus. So the locus is the perpendicular bisector, and that line, the equation of the line we need, passes through the middle point. So it passes through this midpoint, and the next thing we need now is the gradient. So how do we get the gradient of this locus that passes through this middle point? So the gradient is going to be gotten from the gradient of the line VW. So what we need to do now is gradient. So we need to get the gradient of VW now. So the gradient of VW is going to be equals to, so you know how we do gradient, we say y2 minus y1, which is 5 minus 1 divided by x2 minus x1, which is 3 minus 1. Then without wasting time, the answer of this is 5 minus 1, you get 4. 3 minus 1 will give us 2. So 3 over 2, which is also equals to, so the answer is 2. So the gradient of, okay, so the gradient of this now, the gradient of VW now, line VW is 2. So let's put line here, gradient of line VW is 2. So if the gradient is 2, and we said it's a perpendicular bisector, and since it's 2, they now say therefore, now let's take M1 as gradient of the locus. So therefore now gradient of the locus now, if I take it as M1, the gradient of the locus will now be equals to minus 1 over 2. We use condition for perpendicular line. Take note of that. Condition for perpendicular line says you multiply the two gradients, it will be equals to minus 1. So that is what I did to get the gradient of perpendicular line as minus 1 over 2. So with this now I can get my equation. So now say the equation of the locus is, so now the equation of the locus is now, so we use this equation y minus y1, which is y minus y1. Remember the formula, y minus y1 is equals to m, which is the gradient, you open bracket and close, x minus x1. So this is the equation we are going to use. Then now our 2 point has been known. Since our 2 point has been known now, okay, our midpoint has been known where the locus passes through. Since the point is known, so that is x1 is 2, y1 is 3, it's known. Then gradient is also known as minus 1 over 2. So with this we can finish our solution on this page. So you have y minus, so y1 is 3, which is the second coordinate, equals to minus 1 over 2. Then you open bracket, x minus x1 is 2, the midpoint is 2, which is 2. So that is all you need. Then you can finish your solution by putting this equation in the right order. When you cross multiply each term by 2, you are going to have 2y minus 6 is equals to, when you open the bracket with minus 1, it's going to give you minus x plus 2. So minus 1 with times s, minus s, then minus 1 times minus 2 is plus 2. Then our final answer, when you represent it in general form now, let's bring x to this side. We are going to have x, negative become positive, s plus 2y, then minus plus 2 become minus on the other side, which is minus 6 minus 2 equals to 0. The final answer is x plus 2y minus 6. Sorry, minus 6 minus 2 is minus 8. Minus 8 equal to 0. So this is the equation of the line, that the equation of the locus now, that has a particular point P which have equal distance PV and W. I can demonstrate this in my graph page to check if this answer is correct. Just watch what will happen. Let me demonstrate it. Let me remove this. Let me delete this. Okay. So if I type in that equation that we got, to be sure that our answer is correct, you will see that the equation is going to pass the middle of these 2 points. It will pass through the center, and if we check the angle between this line and that line and the equation line we are going to get, it's going to give us 90 degrees, because that is what the question says. Now find the equation of the locus of this point P such that PV and PW, they are equal. You can see, and PV is this point, W is this point. I mean, and because from the explanation of the question we said that locus is a perpendicular bisector, so we need to get equation of the perpendicular bisector. That is the only equation that can pass through the middle of V and W, that will have this condition of PV equals to PW. So let me type this equation. Let's see the line we are going to get. X plus 2y minus 8 equals to 0. I have x plus 2y minus 8 equals to 0. You can see that it passes through the middle of these 2 points. So this is actually the center. If you measure the angle, you see that you are going to get 90 degrees between these 2 lines. This let me put it in 180 so that we can see it. So I need something of 0 to 180. You can see it 90 degrees. So that is it with this question. So you should be able to interpret your question when it comes out in exam. You can see that the angle is 90 degrees. You can see the angle is 90 degrees and it passes through the middle. So that point, to this point, you can see the answer we got. This point, you can see that when x is 2, the midpoint, when x is 2, y is 3. So actually the perpendicular bisector, the locus passes through the middle, passes through this point when x is 2, y is 3. That is this place. When x is 2, this answer we got, y is 3. So you can see that this answer is correct. So take note of this question, 1999 number 18 JAMB question. So So practice this question and understand it very, very well. Okay, let's study this one. This is taken from 1998 JAMB number 32. So this one is a simple one. It's not difficult. It's just direct and easy. It said if the distance between the point, this and this, is 5, find the value of x. So all you need to do here is to use your distance between 2 point formula. We are not going to waste time on this. Remember our distance formula. We say distance between 2 points is equals to square root of, so this was the formula we derived the other time, x, we say x2, say x2 minus x1, x2 minus x1, then you square the bracket, square, then plus, you open bracket again, so you have your y2 minus y1, then you square the bracket, square. So this was the formula we derived in the topic. So if you go through our video, you see this formula. So this is just the formula you need here. And now distance is given. They said the distance is 5. Just put your 5 there, which is 5 equals to, then square root. Then you do your subtraction, x2, which is minus x, minus x. So x2 is already minus. So minus x, which is going to be open bracket. So minus x minus x is going to be in this bracket, raised to power 2. Then plus, open bracket again, then y2, which is 2 minus 3, then raised to power 2. So that is that. Then you now solve your equation. That's what they mean by find the value of x. You solve the equation and the work is over. So 5 is going to be equals to square root. So minus x minus, so this is going to give us minus 2x. This is minus 2x squared. And when you square minus 2x, so you get minus 2x squared. Then plus, this one is going to be minus 1 squared. Then in your next stage, 5 will now be equals to square root. Then when you square minus 2x, you are going to have 4x squared. 4x squared plus, when you square minus 1, it's going to give you 1. Then the next thing is to remove your square root. To remove square root, you square both sides. So when you square both sides, now, you square both sides so that you can remove this square root symbol here. So by squaring both sides, you are going to have 5 squared will now be equals to 4x squared. 5 squared equals to 4x squared plus 1. Okay, plus 1. So that is it. Then at the end of the day, we take 1 to this side. We bring 1 to this side. We are going to have 5 squared is 25 minus 1. Plus 1 will become minus there, equals to 4x squared. Then the next thing is divide both sides by 4. 25 minus 1 is 24. You have 24 divided by 4, which is equals to x squared. So that is that. Then finally, let me finalize my answer here. Then finally, our answer is now going to be, you have your x squared. X squared is equals to 24 divided by 4 is going to give us 6. Then x squared will now be equal to square root of 6. X will now be equals to square root 6. So by removing square, you square root both sides. Just like to remove square root, you square both sides. So to remove square, you square root both sides. So this is the answer. So that is number 3 question I have in our solution of past questions 1998 number 32. Take note of this. So let's try another question and let's see how it goes.